Alright guys, this is about significant figures, or Sig Figs we call it, and these are just process laws. Just like PEMDAS in math, we have rules that apply to significant figures to figure out how many numbers you need to make a value out of, whether adding or subtracting or multiplying, dividing. So the first thing is to understand what is a sig fig. So a significant figure are digits that in a measurement are either known or estimates. So in a known value in 130.5, our knowns are significant, and the 6 is an estimate, would be considered a sig fig. So we have 5 sig figs. Digits that are unknown are not significant. Okay, so unknowns are zeros, and they usually are placeholders. So for example, 5,600,000 liters only has 2 sig figs, because those zeros after the 6 are just holding as placeholders. So it's not a very accurate measurement. It's more of a very big number, usually, or very, very small number. And the unknowns, since they're unknown, they can't be significant. Alright, so here are some of the rules for sig figs determining how many you have. So the first one's easy. Any non-zero is significant. So any number that doesn't have a zero is significant. 4.23, 129.446, 765. Rule 2, or B, zeros between sig figs are significant. So you can't have an unsignificant figure in between two sig figs. So since the 2 and the 9 are significant, the 0 is significant. The 4, 9, 8 are significant, so 40,098 is significant. And those zeros are in there between numbers are significant. The last digit after a decimal point is significant. So these are estimates at the end. So for example, if you measured 1.2 centimeters and that was on the line of 1.2, you have to add the 0 to make the value an estimate, and that makes it significant. So those zeros after the decimal and after the numbers are significant. And then zeros used in scientific notation as coefficients are also significant. So 6.00, it doesn't matter, it's times 10 to the 9. You're looking at the coefficient, 6.00. So those zeros are after the decimal and after sig fig. So those count. So that's 3 sig figs. And 4.0 times 10 to the negative 4. The times 10 to the negative 4 doesn't matter at all. You're looking at just the coefficient, 4.0. Since 4 is significant and then the 0 is after the decimal, you have 2 sig figs. What's not significant? So zeros used as placeholders are not significant. So if you look at 0.0002, the first sig fig you get to is the 2. So everything before that are just placeholders and not significant. If there are zeros after the 2, then they would be significant, but not before. So you have to get to a real value first. And then if 1,000 is 1 is the significant figure, but these zeros after 1 are just not significant. And then zeros used to draw attention to the decimal point. Again, those haven't reached a sig fig yet. So 0.243 is not, the 0 is not significant. The 2, 4, and 3 are. Okay, so again, you have to reach a significant figure first. You have to reach a real number first to start counting. So here are the rules and some examples. So rule number 1, all digits other than 0 are always significant. So we're going to do some practice. 25 grams is 2 sig figs, 2 and 5. 356.4, 4 sig figs. 47,689 is 5 digits, so 5 sig figs. And 972 is 3 sig figs. How many sig figs in the following measurement? If you said 6, you are correct. All right, rule number 2. Zeros between significant digits are significant. So these are zeros within the number. So you have 2 sig figs within each other. So 409 is 3 sig figs. 30,002, again, you had 3 is sig fig, 2 is a sig fig, so the zeros in between count, and that's 5. 2.010002, okay, so all those zeros are within sig figs, so you should get 7. 10.04, 4. All right, how many sig figs in the following measurement? 902 centimeters. If you chose A, you are correct with 3. All right. Zeros after the decimal, and you reach a significant number. So these 2 rules kind of in one. You have to reach a sig fig first, so you got a real number, and then zeros after the decimal are significant. So 2.0 is 2, 29.300, 5, 1.050 is 4, and 456.0 is 4. How many sig figs in the following measurement? 49.40. If you chose B, you are correct. 4. Rule number 4. Zeros used in scientific notation are significant. So this goes back to the same rule as 3. Any zero after the decimal that you reached a sig fig, so you have to reach a sig fig first. So notice all these have a number first. The zeros after the decimal count. The coefficients and the exponent and the base does not matter. You're just looking at the coefficient. So for number 1, it's 2, 3.04, 3, 1.00, 3, 8.000, 4. How many sig figs in the following measurement? 6.010 times 10 to the 9. If you think the answer is A, you are correct. 4. Zeros used as placeholders are not significant. Rule number 5. So these are zeros after or before real numbers. If it's after a real number, then the decimal, you have to reach a decimal. So for 210 people, your sig figs is only 2. That 0 is just a placeholder. Now, if we put a decimal there, it would change to 3. 0.0002, you haven't reached a real number till you get to the 2, so your sig fig is only 1. And then 0.030, the first sig fig you get to is the 3, so those zeros before that do not count. And the 0 after 3 does count because you reach a significant figure. So the answer is 2. $1 million. Again, all those zeros are placeholders. There's no decimal, so the answer is 1. How many significant figures in the following measurement? 100 million kilometers. If you chose the answer to be A, 1, you are correct. All right, here's some practice. So it's a good idea to pause and see what your answers are. Okay, so I'm going to go through the answers. You should get 3 sig figs for 1. That's rule number 2. 1 sig fig. That's rule number 5. 3 sig figs. That's rule number 4. Scientific notation. Number 4, you should have 4 sig figs. That's rule number 3. And number 5 is 6 sig figs, and that's rule number 1. Okay. So 1 has no zeros. Rule 2 has zeros as in between numbers. Rule 3 has zeros after the decimal. Rule 4 is scientific notation. And then rule number 2 is placeholders. Right. 412. Again, pause, think about your answers, and see if you get them right. 3 sig figs, rule 1. Number 2, 1 sig fig, rule number 5. Number 3, 4 sig figs, rule number 3. Number 4, 3 sig figs, rule number 3. Number 5 is tricky. So the zeros between the 9 and 2 are significant, but the 0 after the 2 is not. So 4 sig figs, and you get 2 rules here. One is the zeros after do not count until you reach a decimal. And then rule 2 is zeros are significant between significant figures. Number 6 is 3, rule 4. Number 7 is 3, rule 3 and 5. Number 8 is 1, rule number 5. Number 9 is 3, rule number 1. And number 10 is 5, rule number 2. All right, what are the rules to show a 0 is significant? So sometimes you have a number, but you need to show it significant. There's 3 ways when you have a bunch of zeros, but you have sig figs. 1, you put a line above the number, not my favorite. Number 2, you display it in scientific notation. And number 3, you can put a 0 or decimal after the 0. So I like 2 and 3 best. Number 1, it can get sticky. Okay. So for 4,000 kilometers, you have 1 sig fig. 4 sig figs for 4,000 with a decimal. So that's the difference between 4,000 without a decimal and then 4,000 with a decimal. Number 3, you have 2 sig figs. Number 4, there's no decimal, so it's 1 sig fig. Number 5, there is no decimal, so it is 4 sig figs because those zeros in between 7 and 1 do count. 6, there is a decimal, so it's 5 sig figs. Number 7, there is a line above the 0, so that's 3 sig figs. Number 8, there's no line or decimal, so it's 2 sig figs. Number 9, there are no zeros after the 5, so it's only 2 sig figs. And number 10, adding a 0 to the 5 changes to 3 sig figs. All right, adding and subtracting. So when adding or subtracting in calculations, you round the answer to the same precision or the least precise measurement in your work. So usually the least number of decimal places. So we have 2.3 plus 1.2356. The least precise number is 2.3. Okay, it has 1 decimal compared to 4 decimals. So when you do the math and you put in a calculator, you have 3.5356, you're going to round to 3.5 because it can only go to the 10th place. Now, we didn't round the 5 because the number next to the 5 to the right of it is 3. So it stays at 3.5. So again, the 10th is the least precise. This is the 10,000ths. So your answer can only go to the 10th place. When multiplying and dividing, you answer to the least number of sig figs. So you have to know how many sig figs each digit you have. So 5.7 times 456.345. So 5.7 is 2 sig figs. 456.345 is 6 sig figs. This is your unrounded answer, so it's very big. So this is where students are like, how much do I need to round? Or how many digits do I need? See, these rules help you answer that right away. So your answer can only go to 2 sig figs. So you have to look at the first number, 2, that's 1 sig fig. If you go to 6, that's 2 sig figs, and everything else goes to zeros till you reach the decimal. So the 6 stays a 6 because 0 doesn't round. You don't round up with a 0 to the right, and then that 1 turns into a 0. So your answer is 2,600 centimeters squared. All right, how do I use sig figs when making calculations? Rounding. So if you round to the hundredths, 10.91 was go to 10.9. I'm sorry, tenths. 10.91 will go to 10.9. Number 2, 15.7, because that's 6 will round up. 14.4, because again, the 5 or greater. Number 4 would stay at 3.2. Number 5 would go to 8.7. And number 7 would stay at 7.33. So those are rounding for, in this case, the tenths. Some practice. Rule for addition. So when we add these up, okay, the rule is you go to the least precise. In this case, it's going to go to the tenths. So 1 decimal, 3 decimals, we're going to go to the 1 decimal place. So when we unround an answer, we have that 84.607. We round to the first decimal, which is the tenths, so the answer is 84.6. Subtraction, same idea. You have 6 decimal places on the top, you have 4 on the bottom, so your answer can only go to 4 decimal places. So when you do the subtraction, your unrounded answer is this 53.560356. Again, students are going to ask, how many digits do I need? You round based on the rule. So you look at the 4th place, which is the 3 right here. It rounds up because the 5 next to it. So 53.5604. Addition, 2 decimals, 4 to 5 decimals. Which one are you going to round to? You said 2. Very good. And your answer is going to round to 2 decimals. When you do the math, I get 15.71923. So the second decimal is the 1. And then is that going to round up? You betcha, because it's going to go to 2. So 15.72. More practice, 8.9 minus 5, 1 decimal, 1 decimal. So it doesn't matter which one you choose, they're both going to be 1 decimal place. So when you do the math, 3.9, that's your final answer. 15.2 minus 6, 1 decimal, 0 decimals. So you're going to round to 0 decimals. So when you do the math, you get 9.2. So you round, you start with a 9, that 2 is going to stay, makes the 9 stay a 9 because the 2 is not 5 or greater, so 9 kilometers. More subtraction. So we got 3 decimals, 1 decimal. The answer is going to be 1 decimal. When you do the math, 15.478. Is it going to round up? You betcha, 15.5. All right, so how do we use sig figs when making calculations? So you just have to make sure you know how many sig figs you have, and that's going to be your answer. So when multiplying and dividing. So there's 3 sig figs in 6.02. There's 2 in 5.1. So your answer when you multiply or divide, you're going to have 2 sig figs. 4 in 3.001, 3 sig figs. So your answer can only be 3 sig figs. 3 sig figs in number 3, 2, 4.2. So your answer can only be 2 sig figs. 2 sig figs and 2.0, 1 and 3. So your answer when you multiply or divide, it can only be 1 sig fig. 2 sig figs for 16.00 is 5 sig figs, with 3.021 being 4 sig figs. So your answer can only be 4 sig figs. Okay. So always go by the least number of sig figs when you're multiplying or dividing. So multiplying, dividing, measurements, round off your answer so that the same number of sig figs as the measurement having the least number of sig figs. So how many sig figs in 6.0 is 2, 4.56 is 3. So your answer can only be 2 sig figs. When you do the multiplication, you get 27.35, so you round 27 to 27 because the 3 is less than 5. Same thing with dividing. 45.678 is 5 sig figs. 5.00 is 3 sig figs. So your answer when you divide can only have 3 sig figs. So when you do the math in your calculator, I get 9.1356. You look at the third sig fig, which is the 3. Does that round up? Yes, because the 5 is greater, or 5 or greater. Okay, so 3 sig figs, 2 sig figs. Answer can only be 2 sig figs. So when you multiply, you round that first 0 to a 1 because that 7 is 5 or greater. So your answer is 31 centimeters squared. 8.47 centimeters squared divided by 4.2. 3 sig figs, 2 sig figs. Answer can only be 2 sig figs. So when you divide, you get that big number. Again, these are all rules that help you determine what you need to provide an answer. So without asking how many numbers do I need, how many decimal places, you know it needs to be 2 sig figs. In this case, 2.0 centimeters. All right, divide. We got 5 sig figs, 4 sig figs. So the answer can only be 4 sig figs. So see this big number here? You're not going to put that in the answer key. You're going to round the 4th digit, which is this 6 here. And it's going to stay a 6 because the number is 2 next to it. 3.001 is 4, 5.2 is 3. So the answer can only have 3 sig figs. So you round at 15.6. 2 divided by 3, 2 sig figs, 1 sig fig. Answer can only be 1 sig fig. And 0.6667, you're going to round to 0.7. 1 sig fig. Things to remember. Zeros, rule number 1, zeros are placeholders. I'm sorry, zeros used as placeholders are not significant. Addition and subtraction, round to the least precise. Multiplication and division, you round to the least number of sig figs. Don't round till you have finished all your work. So when you do multiple calculations later on in chem, you don't round to the end. All right, so you want to make sure you complete your fill-in notes and do the practice after those notes as well. And then if you have any questions or anything like that, please ask. And we'll be moving on to the last section on dimensional analysis soon. Thanks.